APIs. Without further ado, I'll give Daniel the stage.
My name is Daniel Kocot. I work for Codecentric in Germany, and I have a double role at Codecentric. On the one hand, I'm a senior solution architect. On the other hand, I'm head of API experience and operation. So all the stuff Eric also already talked about is on my side, and even also the operation side. So that's why we talk about APIOPS. If you would like to connect with me, you find me on Twitter, you can find me on LinkedIn actually. So just get in touch with me if you have questions and so on after to talk to really get into more details about it. So when we think about ops, the whole DevOps thing, the whole CI/CD pipelining and all the stuff around, we have a lot of buzzwords actually in the market. Everyone wants to talk about DevSecOps and all the stuff around DevBizOps and all the things. Delivery is everything, and everything should be code and all the stuff. So, but that's not what I would like to talk about. So no buzzword bingo in the end. And we get more into more detailed view about what really means DevOps. So everybody is thinking about DevOps just about automation. We automate all the things, nearly 80%, and we are doing DevOps. But that's not really the point regarding to DevOps when we get into touch with the COMS model, actually. DevOps is, on one hand, about collaboration. So I have to collaborate with the people I work with. I have to really be aware to share knowledge and all the stuff, doing this in collaboration so far. So we have one point about collaboration. The second point might be automation, but not automation to the end. So it's still the 80-20% rate in somehow. So we automate things. And when we think about DevOps, we should think about lean principles and processes. So maybe something like agile stuff, Scrum, and maybe Kanban as a process actually to evolve within our process over time actually. And the third important step is actually measurement. So we have to measure things we do. That's all. Some things we talked about with APIs. Eric talked about it earlier. So we need to measure things and see what is happening around. So we really have to think about this measurements actually. And for me, the most important thing about what doing with DevOps actually in reference to the COMS model is the part of sharing. Sharing is so important to all the people involved in processes and to all the people involved in all the processes in reference what we are doing. So even talking at conferences, it's always about sharing things. And this is what makes Codecentric so strong here in Germany. We share a lot actually with people. So we have one of the most biggest tech blogs around in Germany, and we like to share things with people. We like to share, even in projects, we always share things with the customers. We don't say, oh, we do this and do a black box there. So we always do sharing all the time. As I said, it's the most important thing about DevOps, really sharing things you do. So we would like to talk about APIs. So when we look at the world of APIs, we always see this API first. But what does it really mean when we talk about API first? It talks about that the API is the first and often the only interface for customers of an application so far. And the API comes always first before the implementation. So when we think about API first, we don't think about the implementation at first. So it's not the code first side actually. And then API first in reference to documentation, the API should always described or documented or maybe self-descripted. It depends on what we actually use in reference to an API style. And when we talk about APIs, we always talk about API design. And when we reference to vendors around on the market, they always talk about API design first, which is nothing more than really making things up front and designing the API we would like to present to the consumer side actually. And when we think about APIs, we always talk about Open API, and maybe we talk about async API. So everything in the part of event-driven architecture is more the API sync side. And when we talk about RESTful APIs, we have this Open API specification. So with this specification, we can describe APIs in a quite and hopefully easy way to make them understandable to the consumers actually. So when we look at an Open API example, we see it here. It's powered by Stoplight's elements actually. It's not the standard Swagger UI. We see that we get a lot of information actually regarding towards an API. We can talk about responses. We see that we have a GET request as only possible for this endpoint. And we see also examples. We can click them around. We see also response examples, which makes it more easier for the consumers to understand what the API is actually doing. And if we have a portal or something like that, it's also possible to have a little sandbox and send a request and get some example data back to really see what is happening around. The most important challenge actually is in reference to Open API is that we have a lot of specification versions around. So some people are still using 2.0, which is the old Swagger specification. Some people are using 3.0 and so on. So the actually one is 3.03, so that we have the latest release of the 3.0 standard. And the new one, which is a screenshot from last year, August, I think, was at this time 7 months old. And the adoption in the market was really, really low at that time. So when we go now further on in time, we see the adoption rise actually with 3.1. There are a lot of tools. Some of them are actually available that are capable of basics in reference to 3.1, because there were a lot of changes actually in reference what we had into the 3.1 version in reference to JSON schema actually. So it's a little bit interesting to see how the market reacts on it. We see that it takes a lot of time for the adoption of API specification standards actually. And if you want to have a look at the bigger view of tools around available in reference to Open API, you can just type in openapi.tools and you get all the tools that are available in the market. Hopefully they are on this list, and they are listed like into types, so you can find everything you would like to find. And the good thing is you always get to know which standard of the specification is supported actually, which makes it more easier to find the right tooling for the right purpose to do. So when we talk about tooling, it's sometimes easy, sometimes not. So for the things we do in reference to version controlling, it's totally simple to just use Git to implement some kind of Git flow and to really have have not the possibility to write direct commits to the main branch actually, which is mostly important. So we have some guidance actually for that, and we have some regulations on that. So in every change to a specification or to a description actually should be a pull request to the pipeline and even the pipeline itself. So when we start looking at tooling, we always start from a developer setup actually. So everything we would like to use in an operational pipeline should also run on a developer setup, so locally. So that's why we step back and look at this developer setup actually, to set up something for a developer workplace, which we did in the earlier times, so in the beginning of 2000 and so on. So we just started from a developer setup. And having a look at IDEs and editors, there are a lot of them, so I just pointed them out and wouldn't like to really talk about them in difference and how to differentiate them. So that's done by the vendors itself actually. The most thing I would really like to have a look at is this local thing. So do things like validation. What can be done there? We could install Spectral, which is a validator from Stoplight. It's totally open source. You can use it within your pipeline by simply typing in npx spectral, do some linting, and you get an error or not. And that's all. But that's not really really interesting so far is just using some tooling. But with Spectral, and there are other tools available, actually we see some of them later, we are able to create rule sets in reference to the API descriptions rewrite actually. So we can set up rules that are not, or that are not basically part of the Open API specification. There are rules that are more relevant to our guidelines actually, having some description tag around and all the stuff. So we are able to provide these rules around. I have to close the door, sorry for that. And with these rule sets, we are able to really validate the API description we get so far. With validation, there comes always a need of mocking. So I want to mock the API I've created, the API description I've created. So we step in with another tool. There's something also available, open source from Stoplight, which is called Prism. And with Prism, we are able to mock and also proxy the specification we wrote actually. So the description we wrote earlier. So with this, we get a local web server. This is running with an endpoint we created. And so Prism is listening at the server IP, and we can have a look at the description of the endpoint so far. With having a mock server available, we also would like to test locally. But testing is not actually easy. Testing could be complicated. So when we think about doing unit tests with an API, we have to use a BDD framework like Chai or Karate or something else which is available down there at the open source side. So we need a framework actually to write a test suite. And we have to create a test suite based directly on this on the description actually, on the spec. So this is something we have to evolve on ourselves, which makes it complicated to do this testing type of thing. But there's a possibility to create a test suite based on Postman collection. Eric had it in the slides earlier, so there was this place to say, oh, you can have a Postman collection from the description you created. And this is what we would like to, or would I have a deeper look into it to see, okay, what is possible in reference to a Postman collection. By bringing up a Postman collection, there comes up the tooling Portman, which was created by API Deck, and this brings a lot of things out of the box. So we don't have to think about how to test the Postman collection or how to create it. It will be done by Portman completely. So what we need here is we have to mock the API actually, and then just use Portman to run tests against the specification we provided via the mock actually. And with this -n parameter, we are able to provide Newman testing actually. So when we run Portman, there will be a Newman test run also. And with this tested specification, there will be at first a Postman collection created, and if all tests are correct, the Postman collection will be actually saved to a file and presented to the user. And this is what Portman does. We have here the description for our API. We can configure Portman. We can also configure Postman actually, because we are using things in reference to Postman with this Postman collection. And we can run Newman, what we did in this example, and we see that we are also able to upload things to Postman if we have this version available of Postman. So we see here we do this testing against the API, and we see everything is as expected. So the collection run is completed, and in the end, the collection will be written to a file on the disk actually. So we now have a tested Portman collection, which brings up to a second test. We want to load test an API. We want to see how good it is working in reference to the backend and so on. So we can think about a smoke test, we can think about a real load test, we can do a stress test actually, and we can a soak test. For this, we just use K6. K6 is a little test tool provided by the Grafana team, which makes it quite easy to really do the testing in this case. And testing is done via a special JavaScript script. So we normally would have to write it on ourselves, but in combination with the Postman collection and a little tool called Postman to K6, we are able to have these K6 tests provided for us. So with this little scripting here, we are able to make sure that a K6 test is created. And with this mock running, actually, because we are still locally, we can test the K6 script and see what it really does. In this case, it's just testing that the script really works. So we have only one virtual user against the API, but we could create a scenario with even more to really see if the API is consistent of a real much users and a lot of traffic exposure and so on. So this is what we really can test here with K6.
Hi, we are Eficode and we organize the DEVOPS Conference. We think that the modern software development is about creating value as sustainably as possible by minimizing waste and risks. If you think the same, we'd love to speak to you and help you make it real. You can find us at eficode.com. The links are in the description, and have a great time with the DevOps Conference talks.
So we see that the local setup for a developer is ready. So we now can test APIs locally. But we have to think that we would like to move into a CI/CD pipeline, doing some things automated and so on, so that nobody has to test something on their own MacBook or PC or something like that, so that we don't have the thing that it's locally tested by somebody and just throwing it over the wall and said, it works on my machine. So this is nothing we want with APIs actually. So we get back to OpenAPI and learn more about it. First of all, we have the possibility to write a description in YAML or JSON. And for us, in reference to projects we did, we could say YAML is the more human readable style and JSON is more for the machines to be readable. And in the end, parsing JSON is faster. So if you would like to write down a specification, or better say a description, write it down in YAML. And if you would like to put it in an automation, transform YAML to JSON, which is also very simple because we have already a script available, YAML to JSON. So that's all. Because when we look deeper into the structure of OpenAPI, I always like to use this OpenAPI map from API Handyman. We see that OpenAPI is not simple. It's not easy, or as a colleague of mine today pointed out, it's no child play actually, because we have a lot of things we can do within the specifications. We can write paths, they can have a lot of options, they can have a lot of parameters and so on. You see that we all can do things here. And if we would like to do things reusable, we have the possibilities with components and so on. So it's really, really difficult to read an OpenAPI specification directly. So we're always looking at this representation in HTML or something like that. But when we want to write an OpenAPI specification, we have to think about the structure. And maybe we would like to split the structure for reuse and better overview. So we end in something called a design library, which makes sense for error note responses and so on, to really have a design library in reference to guidelines and so on available so that everybody can start easy up from the ground and don't have to think, how are we doing all the error responses at our company? I don't really know. Could I use something like problem plus JSON, or is it too much? Have I used something differently? So in the end, to do something more in a governance way, think about design libraries. And another aspect we really have to think about is, do we hard split an API description, so we reach one file per object, or do you think about a soft splitting so that it depends on the size of the whole document or on the object. So there are things we have really to think about to make the access to an open API description more easy for the developer side or the producer side who's creating the specification, the description. So this is when something like references comes in. So we are able to reference things within the specification, which makes it more readable to us, and it will be more reliant. Because when I use references and I do changes to something like components, elements, my element, I don't have to change this every time I would like to reuse them. I just do a change to the referenced object actually. And I can do references remote, and I can also do them via URL. So I can really split up my design library into a different repository and so on, because I'm always can rely on using the ref parameter actually. But there's also a little dark side. We have to think about the things we did. We split it up something. So we then need to rebundle things to one file again. So there's a new tooling called OpenAPI CLE available from Redocly. And with this little command line tool, it's possible to bundle the specifications in a quite easy, short way and have, in the end, only one file, which is put towards a pipeline or something. So when we go deeper into the OpenAPI specification, we find something called OpenAPI extensions. These parameters were created to handle own or so-called vendor needs. Sometimes you see something like X minus Amazon minus blah, blah, or you have X minus product owner. And you can use these extensions for your own needs if you have processes who are relevant for more detailed information within the description. And these objects can be used nearly everywhere. So we really can rely on this additional objects to make sure that an open API specification is more readable for users to understand what you're doing with the API actually. You also can do something like X minus audience, because there was an audience field available in OpenAPI 2.0, which is not longer available in OpenAPI 3, and where you can define the audience of the API to make sure that you always have in mind for whom you are designing an API. So coming from the specification, we really have to think about a way to find possibilities to get this into a CI/CD pipeline. We can use these extensions. We saw it earlier because we can use this by vendor. We have the possibility to write AWS CloudFormation things. With AWS, we can think about CDK. With Azure, we can think about ARM templates, or use Bicep, which is quite new stuff actually from Azure. And we can have something like Pulumi to make sure that we have a specification which ends up in configuration as code. When we look at this CloudFormation template, we see that we have the OpenAPI's description, and we scroll a little bit down and see here that we now have this extension objects available, which means X minus Amazon minus API gateway minus integrations, which declares the things for configuring an API gateway within AWS. So with this parameter, the API gateway in AWS knows that the API has a mock endpoint actually. So it's just mocking something in the backend. And for this CloudFormation thing, we need also to have a S3 bucket available to place the OpenAPI specification in. And that's the whole configuration for the AWS API gateway stack so far. So we just reference to the OpenAPI description here. And now we are able to deliver an API as configuration as code. It's just typing things down and using things you know from the AWS CloudFormation descriptions. You can also do these things with CDK. You can also do the things with on the Azure side. So it's quite easy to use these things. When we look in the market of API gateways, there are also some other possibilities available. Normally, the vendors have an API for their own in the backend actually, and where you can upload the specification and or the description and find all the things then configured within the API gateway. When we look at Kong, we have additional tooling, something called DAG. That's a tooling for just being able to change configurations within the gateway, and with INSO, which is Insomnia command line interface, we are able to do the things with uploading the specification to the portal and all the stuff that we did with other tooling around actually. With Tyke, we find something like TykeSync, and you can follow the list so on. So it's really important to have a look towards the infrastructure components, which is an API gateway in this case, have to offer actually. It's really important to have a look at it and say, okay, I have to use own tool sets by a vendor, and I cannot rely on what I used earlier. And so there is no real standard available in the market to do things from the description towards presenting the infrastructure with the API available actually. So the idea is to have deployable infrastructure, as we learned, to really make sure that we can deploy a gateway, we can deploy portals with all the APIs, we can deploy hubs, registries, and so on. So that's the idea behind it, to have really deployable infrastructure in reference to the API descriptions we created actually. So, and when we think about automating within a CI/CD pipeline, we have to think about API first at first step, then establish a Git process, think about well-structured and formed API specification, because that's the way or that's the side the APIOPS is looking at. It's not the side an API experience is looking at an API. So we are just looking at how it is configured, how is it structured, how is it formed. We have to think about automated validation. We have to think about automated testing, and in the end, automated deployment of relevant infrastructure, actually. So this is the transformation into automating the things we saw earlier. We can have a look at a small picture we have here. So we have actually a design phase. We have a CI/CD phase. And within the CI/CD phase, the end-to-end automation start. And then we have a deployment phase, actually. So that's the things we saw at earlier CI/CD tooling, that we always start doing this integration testing all the time and prepared everything to deploy things in the end and say, okay, that's a different step, and we have to know where to deploy the things actually. A good question that comes always up from customers actually, do we have to build our own framework for this? no, you shouldn't. You saw a lot of tooling actually, and with an open mind within the market, you see what is possible and what's not. There's a lot of traction still in the market, so there is nothing that's really standardized or anything like that. So we really have to look at the things that were built. So in an earlier presentation of this talk, I used Swagger CLE, which is not more relevant because we have this open API CLE by Redocly. So there are a lot of changes actually. So this is what also we see within doing a talk, that often that there is changes into the tooling actually. So there's tooling available. You should be aware of it and really use it. So there is nothing to build a framework for this. So you don't have to think about, oh, I have to do testing on my own and everything like that. You really have to look carefully in what is possible and what is actually available so far. So maybe you saw that we missed something. Yeah, we didn't talk about SDKs or the building of SDKs because it's difficult and it can be dangerous sometimes. And we didn't even talk about security within the pipeline. So we didn't talk about OWASP, API Top 10, or security best practices. So we just built up a simple APIOPS pipeline. And also what we didn't mention was policies or policy as code. So there's no integration of OPER or Sentinel when we look at HashiCorp. So this is something which even bring more value to the pipeline, which is available so far. So there will be more things to talk about, to integrate, maybe to switch the talk to something like API SecOps or something like that. So to get more relevant of the security part and all the things that actually missed beside the SDK generation so far. So if you would like to read more about it, you can find a lot of blog posts actually on the Codecentric blog. I was honored today by Codecentric writing the most blog posts in 2021. And just you find a lot of things there actually. We have also, if you have German audience available, we have also a magazine called Softwerker. And there you find also some articles about APIs and all the stuff involved actually. So I just get back to the Q&A and maybe we have some questions available.
All right, thank you. Thank you, Danny. Very interesting presentation. Yes, we do have time for a couple of questions. We have from Heiko Böttger. Is API all about HTTP REST? What do you think about other interfaces such as command invocation of tools on command line or Docker containers with all parameters exposed ports, volume, environment variable, etc.? Any proposal on how to describe these interaction points?
Yeah. As I mentioned, we just looked at the local part. So I wouldn't recommend doing something locally with Docker actually, because it's not nothing we should do, because the tooling actually we are talking about, it's just tooling from actually the TypeScript and JavaScript base. So we are just on an MPE actually. So it's available locally, but to be honest, in projects, we use a lot of Docker containers actually. So there's nothing running directly, because sometimes in regards to Prism, it's not possible to run Prism with this command within a pipeline actually, because Prism will not stop on its own. So it's running all the time. So there are actually a lot of things you would do different, which wouldn't fit into the talk again, because it's a really complex thing to talk about. So that's why I'm thinking about the second part actually of the talk, to get more into the dark sides of it. So it's really important to think about things, and it's, to be honest, not so easy. We actually had a customer where we built a pipeline which is called by pipelines within the repositories for the APIs, to be aware that the consumers that are creating the APIs have not to think about what tools to use actually. So we have more governance into it. So there's a lot of things actually happening in the background that are not covered by the talk yet, but they will be followed by blog posts on Codecentric, because we see a lot of things that are not easy that are published as easy when you look at the vendor market actually. Because for every vendor in the API management field, it's totally easy to build APIs. But that's not the truth, actually. So there's a lot of things available, and there are a lot of possibilities, actually. So nothing really to cover in a talk, actually.
All right, thank you. I'd still like to ask one quick question relating to this sort of. You propose a lot of different tools. How steep would you say the learning curve is to getting started with them?
It's in my opinion, it's quite low. I can tell it from the project I'm actually working with a customer on. We onboarded a colleague of mine at the beginning of this year, and she was able to handle the tooling within 2 or 3 weeks, actually. Because this tooling you saw, we were actually using in customer projects. So there's a lot of things actually happening that are reality actually towards what we are doing. So nothing which might happen in some pre-sales presentation or something like that.
Thank you so much, Daniel, for your very interesting presentation. We enjoyed it.